implemented Creo 11 years ago, and we started using Smart Assembly to automate Creo immediately when we started using Creo. But I've been pretty active with learning it for 5 years, and really heavily for the last 8 years. I've taught myself how to use both Creo and Smart Assembly, and I really enjoyed that journey along the way of starting with building those software applications. So who's Xylem? Xylem is kind of a conglomeration of different companies. We're an industry leader in water treatment and transportation. When I say transportation, I'm talking about water transportation. So that's mostly uniformly many various types of ponds. So the treatment division that I work in is comprised of 𝘂𝗶𝗁𝗏, Sanitary, and 𝘂𝗶𝘁𝗏. 𝘂𝗶𝗁𝗏 that I have most of my career with is a company that do water filtration, mostly for the municipalities. Sanitary does biological treatment, and 𝘂𝗶𝗁𝗏 does disinfection. Does everything, ensure the water is clean before it goes out to the distribution. Just a little bit of note here about 𝘂𝗶𝗁𝗏. We're actually this year celebrating 100 years of providing clean water, so we could are good with the math, and the last slide was been with the company about a quarter of its existence. So a lot of history and good people, typical great organization to work with. So I'm going to tell you kind of the journey that I experienced, and I said this is especially with working with 𝘂𝗶𝗁𝗏. There are other companies in Xylem that are also using Creo and 𝘂𝗁𝗏, because it's kind of my story that I experienced. So very early on, when I was the engineering manager for the project execution group, we were having a lot of issues with staffing, getting management to allow us to backfill positions, add headcount. We were having drawing generation was basically the backbone of getting projects out to customers. You're using 2D AutoCAD at the time, and kind of slapping drawings together, quickly pulling through templates, using fast projects, sometimes even just fudging dimensions, not scanning drawings properly, just to get them out the door. So, designers were slow in getting drawings to the project engineers to get them checked. Then they didn't have enough time to check them properly. So this was basically all resulting in a lot of errors and issues that unfortunately occasionally did find their way out into the field. So where do we go from here? My supervisor at the time, while he was actually the head of our engineering 𝘂𝗶𝗁𝗏, of the technical branch of 𝘂𝗶𝗁𝗏. He came to me and said, "Hey Randy, we're thinking we're going to go to Creo." And I said, "Okay, I'm not really sure that's going to work very well because of our ECO type of business. We don't make widgets and stuff. We make a bunch of parts that go into concrete basins, and it's very engineered to order. Each job's different." So I was a little skeptical at first. He explained to me that there are other companies within Xylem that are using this. We're doing because what they're doing is they're automating the CAD data and using the SIGMAXIM to do this automation. So I said, as I said, I was skeptical, but I did have an open mind. I said, okay, we'll see how it goes. So how do we use this automation? What are the ways that we found we could automate this software? It's very flexible. It gives the developer a lot of functions to go about automating to suit the product and their desired work style. You can create They're designed to use multiple GUI strings to prompt the user to go through and make changes as the program is running. Where they just say, I need to know what surface this bolt needs to be assigned to. They can click on that, or where does a hole need to be drilled to the part, if they can go through and make those selections. You can also pull data from Excel. So if you have maybe a bunch of your own Excel sheets that does the design of your product for you. This was the case with Leopold. We had a design sheet that we've been using for over 20 years that does, put all the inputs in, it gives you the design for the filter system. So if you have that type of design, or if you create an Excel sheet, you can actually have it push it out to the software and actually do all that automation for you. You hit a button, it builds the model, come back, walk away and come back, and so you have a full model. Or that's just wow. So there are a couple of different ways that we can do this. Is pushing data into parameters and relations looking Creo, and that's not what SIGMAXIM thing. It's a Creo thing. It's built with Creo. But when you combine those parameters and relations just with the automation, the SIGMAXIM, it gives you a really powerful tools that you use to simply develop your products. And then also we can integrate product rules and formulas right into the code itself. So if the relations that Creo has built into it, it might be a little bit limited in some cases. Whereas with the software, you can have complex conditional statements. You can have while loops that can move through scenarios, and this is really key to being able to do that automation.
Thank you for that.
So how does this look? How does this work? So I'll show you an interactive design where it's going through the multiple GUI strings here. So this one here, this is one that I went through with Sanitaire designer. He kind of walked me through their process to explain what all this is. So I'll show you this here. Initially, you have a selection screen with all the apps in there. So this was a 16-minute video that I squished down to 3 minutes, so it's going to run through here extremely fast. So I'll just pause it just to explain a little bit. So that initial screen, you select whichever app you want to run to build whatever it is that you're building. And then here's making some initial selections. And then this screen is just all the different possible configurations that can be made. And then here we get to the actual SIGMAXIM GUI. So in here is all the inputs for this particular app once you select the configuration. And so basically instantly this rectangular basin is created. And then we want to go through and add some more components to this basin. So we pick another app to add some more. We get another GUI screen. These screens are developed through the software, and these are all custom built. So there's inputs, there's racial buttons, checkboxes, lists that we can pick from. So once you do all those different inputs, then we get some fittings here inside the basin. So what's next? We need to throw some piping in here to connect these fittings together. That's very quick. The piping is all added and connect all these connections together. Now what do we need? We need to pipe the crotch down from the supply down to the manifold. So we'll go through, put in the information for the supply. This message box here pops up, tells the user, and this was programmed in. Okay, because of the length of this pipe, we actually need a support. And so it asks, do you want to add a support? And said yes. Another message box, a little bit of information about the support, and to get the support now. So the last thing is to finish off this assembly what else? We need some headers in here to attach to this manifold. So again, another GUI screen, go ahead and put the inputs in for those headers and distribute the shared caps. And this will just go pull all of the template models from your library, push the data into it that came out of the GUIs, and it'll automatically go through and build all of the headers onto the manifold. Copy message boxes that are coming up about the different types of distributor caps. So there, it's built out a whole assembly. So that's pretty cool. So that's how the GUI screen works there on that one. So the next one I'll show you is what I spoke about earlier about if you have an Excel sheet. You can have that Excel sheet push all the data out to your models for you. So this is a Leopold design. Similar, the same sort of thing here. We'll start with the initial screen where we'll pick an app from. On this one, so what this is it's asking, the very first thing it does is say, hey, where's the Excel sheet on fully emission button? So we'll put this Excel sheet here. And then it just starts running. So it's going to take all the information from that Excel sheet, push it into the models. What we see on the screen here, this is the basin that is the basis for the whole design. If you import the skeleton models, it's very much built off of a skeleton model. It has all the data planes, all the coordinate systems that are needed to reference, assemble everything into assembly. And so it's just going to continue to go on the way through here and grab all the template assemblies and parts, push all that, gives that data from the Excel sheet into those parts and the parameters, relations, and build out all those components, change the size of them, how it needs to be, how we're going to quantities of whatever needs assembled in. That's all mapped here. So like I said, you can do this as soon as you pick that Excel sheet, you can walk away, you can get a copy, come back, and go us up with a completed plot. And so the next step after this will be, once this model is completed, we can actually generate drawings from that automatically. It'll automatically go through, create all the drawing, use, add all the notes that needs to add to it. If you need to, I mean, when it's done, when the model's done, it's just like any other real model. So you can still go in and make modifications to it. There's nothing that this automation does that makes it locked anywhere. So you can still, if you have special cases that you get program in, you can still go through and modify any of those things that you can see about. So this is a completed Leopold filter model. You can see it's got many different components, different sizes, and virtually any configuration of that is possible with the sizes. To see the two differences between walking through the GUIs and then having this kind of on here. One thing that I really like about this way is it gives a very good or a low barrier for entry for new employees. So I can have a product or project engineer fill out that whole Excel sheet, give it to the designer, and then he just runs it and it builds the model. Now I have a designer that knows how to run Creo and make all these changes, and so he doesn't need to necessarily learn the rules and everything top to front. He can create a drawing just out of this quick connect. Just took those in. All right, so where do we end up after the automation? All those errors that I talked about that we were having to the 2D AutoCAD and all that mess, we saw a huge reduction in those errors after all this was all done. I had actually, at the time, before we went to Creo, I had the operations engineer come to me and say, we've been actually tracking engineering errors found at the vendors, at their manufacturers, also in the field, and showed me like a chart of who's making these errors, where they're coming from, what type of errors they are. And after, probably sometime after, a year or so after we had been at this, they told me, your error path is like vastly reduced. So, they cannot switch to Creo. We were able to actually increase our project throughput while maintaining headcount. So we still didn't actually add any additional designers or engineers. We were just getting the work of the drawings completed faster. So we were actually able to complete more projects while maintaining that same headcount. Switching to 3D models, this is obviously we're using the models and parameters to generate film materials, so this is much faster. It's a great selling tool, marketing tool with the customer to be able to show them a 3D model of the system. And we actually have some design engineers who require us to provide 3D models to go into the system. So we took some of that time savings that we had, and we're actually able to improve or even add standards to our company within the engineering department, and further improve our efficiency. So we kind of start now using that time we're saving to do other things that we didn't have time before. Once this is all done, it is a process to get. We were converting from 2D, so we had to generate all these models. Then we were to create all the code. Once all that was done, changing the code, adding to the code. If you have a change in the product, it's very simple to go in and make changes to the assembly code. SIGMAXIM is a great partner as far as providing training. They have the tech support and a forum. You just go on, post a question, and their engineers will quickly come back and provide a response on those questions and help you through either there was a programming issue or actually something not functioning correctly. And we did find out that automation is possible. I have, just like I said to my boss 11 years ago, I talk to people about this, they say, yeah, that won't work for us because we'll be based different tasks. And we found out that open mind, not having a negative kind of opinions or thought process going into it, that anything can be automated to some degree. There's capital plus your system might be. So what are some other ways that we are using this time savings and other ways that we're using Creo? We're actually implemented an engineering change management system with 𝘊𝗀𝗀. So we used to have hand-carried paper copy that get signatures from each person. They get lost on their desk. The typical things that those things difficult existing jury. But we switched into cloud-based, robust engineering change system. It is integrated with Creo. It has automated notifications. They go out to the approvers, they approve them, goes on to the ☂process. At the end, you can actually create ad hoc tasks to give to people to go implement those changes. Then once those changes are done, all of that information that you put into that change process is now linked to it. Those have gone into Creo that made those changes out. You have attachments in there, you can put your emails and support why the change was made and all that sort of signing up. So a couple of things that we're using Creo for. FEA, the top two images, those are parts that we're doing fundamental analysis on. So you can go ahead and see where your stresses and your deflections are to be able to further support or maybe kind of reduce some 𝗬𝗏𝗂𝗧 cost. So that's something that our engineers are actually doing with parts. And then CFD is another thing that we can do with Creo Flow. So this is a really exciting package that we're kind of just starting to scratch the surface with. But we think it could really give us a great insight into the flow characteristics of our systems and give us a competitive advantage with our customers because we can actually have the ability to do a flow analysis of their system. And so the pictures that you see here on the bottom, those are open channel flow that 𝗂𝘁𝗏𝗏 doing on somewhere 𝗫𝗏𝗁 Cisco. All right, so what do we get out of this? What are the takeaways here? We had fewer manufacturing errors. We were able to save time, increase consistency, get better communication with our customers. We did find out that we can, even though we have a complex CTO system, we are able to benefit from Creo automation. We discovered that it's really easy to write new code, maintain that code, make updates with working with SIGMAXIM and providing support along the way. We're able to get more out of our Creo investment because of the time savings. And so we're using that time to increase or develop other processes of our company utilizing Creo. So, any questions about the event?
So that's really impressive, and my inspirational that you can do that much easier to order. My favorite part is at the end, then get the model and start to do whatever.
Right, absolutely, yeah.
That and the fact that at some point in the cycle there, the sub-assembly got a little 𝗬𝗏𝗏𝗏, kind of like, look at me, what I've already done. So any questions for Randy?
I'm just intrigued how the clients of yours reacted to not being handed at 2D ADM.
How did the clients react to?
Yeah, AutoCAD is obviously extremely large in the architectural and building space. So you picking PTC in this space, how does that react when you?
So we still do create 2D drawings from the 3D models, and that's why I said that's what's really great with the improved customer communication, because we went from having maybe two or three drawings to now we can do 4, 5, 6 drawings in the same amount of time because we have a 3D model that we can slice through, add images or add views to with all the notes, all that drawing automation is. Or all those drawings generation is automated. So we're still providing 2D drawings because that is the industry standard. But like I said, there are some engineers that actually do request for 3D models. So having that, like it's actually in the spec that we have to do it. So having that ability to be able to provide them with that and to be able to show the customer those 3D models of what the stuff actually looks like and not just rely on some views on paper is really this. Okay. Any other questions? Well, then do that back.
Hello. Yeah, I think that's great. I really love this automation. My question is, if you have these multiple input systems, like a spreadsheet, so we give this to sales, they talk to customers, they want X, Y, and Z. How do you handle like conflicts? So like geometry conflicts where they make something that's not physically possible to fit in the box.
So there you have to, you do have to build the guidelines and rules either in the Excel sheet. So that stuff needs to be designed either in your Excel sheet or in the code, the Smart Assembly code.
So you do that in the GUI, like in your form, you're limiting your inputs, and
right.
You're setting like the strings to say it starts from here, you can only go that way.
Yep. Yeah, exactly. And so if if somebody doesn't do that, I mean, when that automated build is running, it'll fail, and it'll actually, it's very nice because it gives you the line in the code where it failed at. So you can go right to that line if you're not even sure why it failed. You can go into the code, see what it's trying to do at that time, and then rectify that throughout that. But yeah, it's obviously not just going to build something that's impossible so that the Smart Assembly app will fail. But like I said, it shows you where it fails. But like I said, the way to get around that is to build the rules and the guidelines into the Excel sheets, the GUIs, and then the code.
But if you made like a complicated like 3D layout, and I guess you limit the number of parameters and all that.
Yeah, I think in the Leopold one, the second video that I ran, like we have 130 or so parameters that actually come from the Excel sheet and go back to that get pushed into the models. So there's a lot there. But again, so in that example, like I said, the basin is the skeleton model. It's got everything built out for every single possibility that we could have. And then it'll suppress a bunch of stuff if it's not used. But that's what governs the layout of everything, and like I said, limits how many things of what type, what length, and what not can be put in.
Really impressive. Thank you so much.
Contact SIGMAXIM at info@sigmaxim.com for more information on our groundbreaking Creo automation solutions.